Hello everyone and welcome to another episode of Astronomy Answered Simply. Today's question, we're jumping right in. Are galaxies formed from accretion disks of ginormous star hypernova explosions? Sort of. Galaxies are not formed in directly by star hypernova explosions and accretion disks. Stars are formed by accretion disks and create hypernovas. Those would be supermassive, hypergiant stars would create hypernova explosions. And they would leave behind black holes. Black holes would be the foundation of galaxies. And the supermassive black holes at galaxies are the result of multiple black hole mergers plus black holes pulling in or absorbing matter around them and having such strong gravitational attraction as to pull in massive amounts of, well, mass. So it directly, no, but indirectly, yes. It would be the long and short answer of this. The article you're referring to talks about how, there's a handful of galaxies trapped in this spider web of gas and dust in the universe, and it shows them to be about 1 billion years after the universe was created. So the universe would have been much more dense than it is now, and so we're talking about 13.5 billion years ago-ish, based on the age of the universe, or approximate age of the universe. So there's much more matter, much more density. Stars and stars and black holes can pull mass or, gravitationally bind mass to themselves very quickly. And then these 6 objects were also pretty much, judging by their, given the information in the article, is they're gravitationally bound to each other, but they're at enough distance where they're not collapsing upon or falling in towards each other, or I should say exerting enough force as to slowly merge with each other. Although if we could hang around for a few billion more years, maybe we'd see them merge. Depends on their momentum with respect to each other. It's something that would take probably hundreds of years to watch to determine, the redshift, blue shift, and their momentum in relation to each other and how they are gravitationally interacting. So, the long and short of the answer, 1, it's a really cool find by the ESO, and 2, galaxies are sort of formed in accretion disks, but galaxies are really formed by the leftovers of stars that accreted. So, yes, a galaxy looks like an accretion disk, but it's not. It's I guess it sort of kind of is. It's fuzzy in the cosmological model, but basically where areas where star formation happens and we're in this giant galactic plane. I apologize for the lack of any kind of special effects here, but we're in this giant galactic plane and we are orbiting the center of the galaxy. Like, say, here's the center of our galaxy, and we're going around and around and around, in every 225 million years. Early galaxies were much smaller, but they've had time to gather and collect and have stable, massive amounts of gases gravitationally bound to that center point, which is the center of the galaxy, or approximately the center of the galaxy. The whatever supermassive black hole. In our galaxy, it's Sagittarius A star. In Andromeda, I am blanking on the name for right now, but the supermassive black holes at the center of galaxies were once hypergiant stars. So in a way your question's correct, in a way it's a little bit off, but it just requires clarification. But the hypergiant stars in the early universe grew, lived, died, fused, exploded into their hypernova explosions, left a black hole. Those black holes traveled throughout the universe, gathered more material, collapsed more material in upon themselves. Multiple black holes have merged, and they become the supermassive black holes at the center of galaxies, and gravitational, have a gravitational force that can bind objects hundreds of, thousands and thousands of light years away because of their massive their massive gravity and the effect of that mass, plus whatever. This is where cosmology gets fuzzy on the galactic scale, plus whatever dark matter is hanging around them and helping bind our galaxies together, because there isn't enough mass visible in the universe to actually keep our galaxy from unraveling, or most galaxies from unraveling, because the mass that we can see in our black holes and the stars and the suns and the nebula and the gases and the dust clouds is actually insufficient to counteract the centripetal force of the angular momentum spinning around the galaxy. So in reality, we should be all flying off in a million directions, but that's why we call it dark matter, and we don't know what it is yet. But there's another force that has the same effect as gravity, but we can't see it, that kind of keeps the galaxy together. So there's still so much we don't know about our own galaxy, let alone even our own solar system. Heck, we're still learning about our planet. We are infants, and we have so much to learn, and there's so much to discover. So my request, keep looking up, keep wondering, keep asking questions. If you don't ask questions, you're not going to find the answers. So thank you for asking this. I hope I've helped clarify just a little bit of your questions based on that. And we'll see you all tomorrow. Like, subscribe, send me questions on Quora, Facebook. If you have my email, for the very, very few of you who do, send me an email. Have a great day. And if you're a teacher, I'm happy to pop into classes and talk about astronomy. If you're an educator or any other educator of any kind, let me know if you want me to talk. I love to talk about astronomy. Thank you very much, and have a great day. Bye.